Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 32 video on the chapter of mensuration, where I will solve some miscellaneous problems on how to find the area of shaded region which are specifically based on circles and other figures like squares, rectangles and triangles. But specifically this is based on the circles. So if you have not watched the previous 31 video on this chapter of mensuration, where I have covered all the concepts of area and perimeter of different figures, then I strongly suggest that you also watch those videos to maintain the continuity of your study on the chapter of mensuration. This video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with part 32 video on the chapter of mensuration, where I will solve miscellaneous problems of how to find area of shaded region based on circles. Okay, so there are 6 problems, total 6 problems. I've written down the problems and hopefully I have given the choices correct, but I'm not sure. Let's see, let's focus in how to solve the problem and apply the concepts of circles, area and perimeter of circles and other related figures. Okay, so the first problem says there is a figure. It says that PQRS is a square of side x centimeter. Okay, and two semicircles are drawn inside of it with PQ and SR as diameters. The area of the shaded region is. Okay, so so PQRS is a square. So we have this side is also x, this side is also x, and this side is also x. So the two semicircles are, let's mark the two semicircles. Let's say C1 is the first is the top semicircle and C2 is the bottom semicircle. Now as you can see that both the semicircles have diameters equal to the C1 has the semicircle C1 has the diameter equal to, so we can say that diameter of C1 we can see from the figure will be SR, which is equal to x, and diameter of the semicircle C2 will be PQ, which is also equal to x, as PQRS is a square having each side equal to x centimeter. Okay, now we have to find the area of the shaded region. So quite obviously the area of the shaded region is nothing but the area of the square minus the area of the two semicircles. Okay, now okay, so what is the area of the semicircle C1? Area of the semicircle C1, we know area of a semicircle of radius r is pi r square by 2. So semicircle is half of a circle, so its area will be half that of a circle. So area of C1 is pi. Now remember that diameter of C1 is x. Diameter of C1 is x, and the diameter of the C2 is x. That is, diameter of both the semicircle is x. And what is the area of a circle in terms of diameter? Area of a circle, if it is capital A, in terms of diameter, it is pi d square by 4, which is equal to pi r square, where r is the radius. In terms of d diameter, it is pi d square by 4. So area of the semicircle C1 having a diameter x will be pi x square by 4. Okay, and also and the area of the semicircle C2, it will also be equal to pi x square by 4, because for the semicircle C2, both the semicircle C1 and C2 are having diameter x. But I'm wrong. The area of semicircle C1 will be not pi x square by 4, but it will be pi x square by 4 divided by 2, because it's a semicircle. Area of a circle having diameter d is equal to pi d square by 4, but area of a semicircle is half the area of a circle. So the area of the semicircle C1 will be pi x square by 4, this whole divided by 2, which is equal to pi x square by 8. Similarly, area of the semicircle C2 will be this divided by 2, which is equal to pi x square by 8. Okay, so area of shaded region is nothing but area of the square, which is PQRS. Area of the shaded region is nothing but area of the square minus the area of the two semicircles. So minus area of C1 minus area of C2. This is equal to area of the square is x square, and area of C1 is pi x square by 8, and area of C2 is also pi x square by 8. This is, after simplification, becomes x square minus we have pi x square by 8 plus pi x square by 8. This is equal to x square minus 2 into pi x square by 8, which is pi x square by 4. If I take x square common, I have x square 1 minus pi by 4. This should be the area of the shaded region. What are the options? Okay, so this is equal to, if I simplify 1 minus pi by 4, this will be x square 4 minus pi whole divided by 4. So x square by 4 multiplied by 4 minus pi, which is choice C. So the answer is choice C. So the concept was that, as you can see that the concept was to understand that the diameter of the two semicircles are equal, and which is equal to x, that is the length of the side of the square. And also you must know what is the area of a semicircle having a diameter, having a given diameter. Okay, let's see the next problem. Okay, so we have O is the center of a circle of radius r. So we can see a circle. O is the center of the circle and r is the radius. Angle AOB, so A and B are 2 points on the circle, and angle AOB is 60 degree. Find the area of the shaded region. Okay, so we have a triangle AOB inside the circle having with center O and radius r. Okay, so the concept is that in triangle, we can see in triangle AOB, we see that OA is equal to OB, which is equal to R. OA and OB are radius of the circle, because A and B are 2 points on the circumference of the circle. So OA will be the radius, and OB, the length of OA and length of OB, they are all both will be equal to the radius of the circle. Okay, so we have so this implies that in the triangle AOB, OA is equal to AB. So this implies angle OAB should be, so this is an isosceles triangle. So from the fact that OA is equal to OB, in a triangle we can say that the opposite angles should also be equal. So angle OAB should be equal to angle OBA. Now, so this implies okay, also we know that in a triangle we know that angle A plus angle B, the sum of the angles in a triangle is equal to 180 degree. Okay, Now this actually means angle OAB is nothing but angle A. Angle A is equal to angle B. And we have angle A plus angle B plus angle O is equal to 180 degree. This implies, let's say angle A, angle B, we can write angle B as angle A plus angle O is 60 degree. This is 180 degree. So this implies twice of angle A is equal to 180 degree minus 60 degree, which is equal to 120 degree. So this implies angle A is equal to 120 degree by 2, which is 60 degree. So we can see all the angles of the triangle OAB are equal to 60 degree, which means that it is a equilateral triangle. So triangle OAB is an equilateral triangle. So what will be the area of the shaded region? It will be the area of the circle minus the area of the triangle. So we can say, we know that area of an equilateral triangle in this the triangle OAB is an equilateral triangle of where the length of each side is r. Length of each side is r. Since OA is the length of OA and OA is equal to r, and it is an equilateral triangle, so the length of all the sides will be equal to r. So area of the equilateral triangle OAB then becomes, we know that area of an equilateral triangle of side A is, so the area will be square root of 3 divided by 4 and r square. This is the area of the triangle OAB. Now what is the area of the circle? Area of the circle is equal to pi r square. So this implies area of shaded region, area of the shaded region is equal to area of circle minus area of the triangle AOB, which is equal to pi r square minus square root of 3 by 4 r square. Okay. In all the options you can see that we have a pi square as a factor. So from here, let's say we take out r square as a common factor. This becomes r square multiplied by pi minus square root of 3 by 4. Now what if, now this is equal to, if I want to take out pi as a common factor from pi minus root 3 by 4, it will be, so this is pi, let's say square root of 3 divided by 4, we can write it as square root of 3 multiplied by pi divided by 4 pi. That is, we can in a rational number, even though square root of 3 by 4 is not a rational number, still so square root of 3 by 4 is definitely equal to square root of 3 pi divided by 4 pi. So we have this. Now I can take pi common from the expression inside the bracket, and this becomes pi r square 1 minus square root of 3 by 4 pi. This should be the area of the shaded region, pi r square 1 minus square root of 3 by 4 pi. So the correct choice is D. D is the correct choice. Okay, let's see the next problem. Question number 3. Two identical circles just fit inside the rectangle ABCD of length x and breadth y. So there is a, okay, the area of the shaded region is, okay, so we are given a rectangle ABCD whose length is x and breadth is y, and the two circles inside, they are identical circles. Identical circles means they are having so identical circles means their radius is equal. So identical circles implies equal radius. That is, the radius of the two circles are equal. Okay. And the circles just fit inside the rectangles. That is, these points are touching the edges of the rectangle. So if we consider the circle with center P. It is touching, let's say it is touching the points where it touches the sides of the rectangle. Let's say they be this point PE and this point BF, this point BG, and the circle with center Q, it is touching at the point H, and let's say I, and this be J. Now one concept is that, so these two circles with centers P and Q, they are also they just fits inside the rectangle, so they are also touching each other. As you can see, they are touching each other at the point, let's say this be K. So if the two circles are touching each other at the point K, and then this means that the point K will lie, the point K and the two centers, they will be collinear. They lie on the same straight line. They will be collinear. Okay. And since the circles and also if I extend the line joining the centers, that is PQ, farther, then it will also meet the, so if I extend PQ to the right hand side, it will meet the point I, that is where the circle of center Q is touching the rectangle on the side DC. And if I extend PQ, the line segment PQ, to the left hand side, it will meet the point E, that is where it is touching the side AB. Now the two circles are identical, means that their radius are same. Let's say, so PK will be the radius of a circle with center P. So this will be, let's say this is R. Also we will have in fact, so we have, let's say it is asking the area of the shaded region is, okay, so let's say the radius of the each circle be R. Each identical circles, they will both have the same radius. This will be R. Let's say the radius of the circles is R. Okay. So we will have we will have EK. EK is the diameter. EK is the diameter of the circle with center P. So it will be twice R. And KI will be the diameter of the circle with center Q. So it will be also be twice R. Since the two circles are identical, the radius are same, R. Now what is EK plus KI? EK plus KI is nothing but it is the side of the, we can say this is BC, or this is equal to AD. That is the length of the rectangle ABCD, which is equal to X. So this implies, what is EK? EK is twice R. And what is KI? KI is twice R. So twice R plus twice R is equal to X. This implies R. This implies 4R is equal to X. This implies R is equal to X by 4. R is equal to X by 4. Okay. R is equal to X by 4. Okay. So we have to find the area of the shaded region. Area of the shaded region is nothing but the area of the rectangle minus the area of the two circles. Okay. So what is the area of the circle? So area, let's say this be circle C1 and this be circle C2. So area of circles, since they are identical circles, area of circle C1 is equal to area of circle C2 is equal to pi r square. Pi r square. Okay, pi r square. Now the choices are all given in terms of y. Okay, y. So area of C1 circle, area of both the circles is equal to pi r square, and we know that r is equal to x by 4. So this we can write as x by 4. Okay, so this will be pi, r is x by 4, so x by 4 square, which is equal to pi x square by 16. Okay, now also another thing to note is that the diameter of each circle, okay, so also note that the point, for consider the circle with center P, it is touching the sides AD and BC at the point G and F. So GPF, this will be the point GP and F, they will be collinear, and GF will be the diameter of the circle. Similarly, the point HQ and J, they will be collinear, that is they will lie on the same straight line, and HJ will be the diameter. Now what is GF? GF, so GF will be equal to, since it is the diameter of the circle, so GF is equal to HJ is equal to twice R, since we have considered R to be the radius of the circle. Okay, now what is now please note that the GF and HJ, they are also equal to the breadth of the rectangle, that is AB or DC, which is equal to Y. So we are having also twice R is equal to Y. We are having twice R is equal to Y. Okay, so this implies that R is equal to Y by 2. Okay, so we got R, the radius of the circle, in terms of the breadth Y. So this implies that the area of circle C1 will be equal to area of circle C2 is equal to pi r square, and R we know is Y by 2. So R pi Y by 2 square. Okay, this is equal to pi Y square by 4. So area of each of the circle, each identical circle, is pi r square by pi Y square by 4. Okay, so twice R is equal to Y and X is equal to R. So we have X is equal to, we have this R is equal to X by 4, and we also have R is equal to Y by 2. R is equal to Y by 2. So this implies that X by 4 is equal to Y by 2. This implies that if I do cross multiplication, 2x is equal to 4y, this implies x is equal to 2y. So please note that in this kind of scenario, in a rectangle where two identical circles are fitting inside exactly, then the length of the rectangle has to be twice the breadth. So we are having x is equal to twice y. Okay, fine. Now what is the area of the rectangle ABCD? Area of the rectangle ABCD is equal to length into breadth, which is xy, and x we know is twice y. So this is twice y multiplied by y, which is 2y square. And what is the area? The sum of the area of the two identical circles, that is area C1, area C2, the area of the two identical circles will be equal to 2 multiplied by the area of each circle, which is pi y square by 4. Pi y square by 4, this is equal to pi y square by 2. Therefore we can say area of shaded region, area of shaded region will be equal to area of the rectangle, which we have found to be 2y square minus area of the total area of the two circles, which is pi y square by 2. Pi y square by 2. Okay. If you take y square common, we have 2 minus pi by 2. Okay. Okay, so this is equal to, if we simplify 2 minus pi by 2, this becomes 4 minus pi divided by 2. So this is y square by 2 multiplied by 4 minus pi. Y square by 2 multiplied by 4 minus pi is the area of the shaded region. So the correct choice is choice A. Choice A is the correct choice. So the important concept was, since the two circles are identical and they are just fitting inside the rectangle, as you can see that the diameter of the circle will be equal to the breadth, has to be equal to the breadth of the rectangle, and the sum of the twice the diameter of each circle will be equal to the length of the rectangle, and hence we must have the length of the rectangle must be equal to twice the breadth of the rectangle. Okay, let's see the next problem. Question number 4. ABCD is a square having an area. ABCD is a square having an area of a square units inscribed in a circle. Inscribed in a circle. Then the perimeter of the circle is. Okay. Now, whenever a square is inscribed in a circle, so ABCD is the square which is inscribed in a circle. Always remember that the diagonal of the square, that is BC or AD, they will be equal to the diameter of the circle. Diameter of the circle. Or in other words, the diagonal of the square AD and BC, if they are intersecting at the point O, O will also be the center of the circle. And OC, OD, OB, AO, they will be the radius of the circle. So this will be the radius, this will be the radius, radius. So will be the radius of the circle. Now we have to find the perimeter of the circle where the area of the square is given. Area of the square is given. Okay. Now, so we are having that if we consider R to be the radius of the circle, let R be the radius of the circle. Let R be the radius of the circle. Then we will have AD. AD is equal to AO plus OD, which is equal to R plus R, which is twice R, or AD will be the diameter of the circle. Okay, and AD is also the diagonal of the square ABCD. Now area, it is given that area of the square ABCD is equal to A. So this implies, since ABCD is a square, this implies that AD, which is the diagonal of the square, will be okay. So this implies that AC equal to DC. These are all the sides of the square and they are equal. BD equal to AB has to be equal to square root of A. We know that for a square, area is equal to the square of the side. If x is the length of the side of a square, then area is x square. So we can then say that the length of the side of a square of area A is equal to square root of A. So we are having the length of each side of the square that is AC or DC or BD or AB is equal to square root of A. Now we also know that in a square we also know that the diagonal is equal to square root of 2 multiplied by the length of each side of a square, that is x. Diagonal is equal to square root of 2 multiplied by length of each side of a square. So in this figure we must have AD equals to BC should be equal to square root of A multiplied by the length of each side of the square, which we have found to be square root of A. So this is square root of twice A. Square root of twice A is the length of the diagonal of the square ABCD whose area is given to be A. And we also know that AD is the diameter of the circle. So we have twice R is equal to square root of twice A. So this implies R. Okay. So now the question has asked the perimeter of the circle. So we can say that perimeter of the circle we know is equal to 2 pi r, which is equal to pi into 2r, and 2r we have found to be equal to square root of 2a. So this is equal to pi into square root of 2a. Pi into square root of 2a is the perimeter of the circle. So the choice is D. Answer is choice D. So remember that a square inscribed in a circle has the diagonal equal to the diameter of the circle. So this is the basic concept. Okay, let's see the next problem. Question number 5 says there is a figure. The figure has two identical small circles within a big circle. AB is the diameter of the big circle. Okay. AB is the diameter of the big circle, while X and Y are the centers of the small circles. Okay. The ratio of the area of the shaded part to that of the big circle. So I am sorry, I forgot to highlight the shaded part. The shaded part is this part. This was the shaded part. My shading will not be perfect, but I hope you will understand. This is the shaded part. So basically the shaded part is nothing but the area of the big circle minus the area of the two small circles. Now the two small circles are identical, that is they will have the same radius. So we can see that AB is given to be the diameter of the big circle. AB is given to be the diameter of the big circle, and so if we consider the radius of the smaller circles to be r, let's say this be r, that is ax, let a radius of smaller circle be r. So we can see that ax, let's say that the two smaller circles touch at the point, let's say P. So we must have, if we consider small r to be the radius of the two identical smaller circles, then we have ax is equal to r, and also AP will be equal to twice r. AP is the diameter of the small circles, of the smaller circle, with center at x. Similarly, let's say we will have by will be equal to r, and BP will be equal to twice r. Now this implies, what is AB? AB is nothing. AB is AP plus PB, which is equal to AP is twice R and PB is also or BP is also twice R. So this is equal to 4R. That is, the diameter of the bigger circle is equal to the sum of the diameter of the smaller identical circles. So we have AB is equal to 4R. Okay. Now the problem was asked the ratio of the area of the shaded part to that of the big circles. Okay. So let's say the big circle BC and let's say the top smaller circle be C1 and the bottom smaller circle be C2. So what is area of the big circle C? This is equal to pi AB square by 4. Since AB is the diameter of the circle, bigger circle, we know that if D is the diameter of a circle, its area is pi D square by 4. So for the bigger circle, diameter is AB. So its area will be AB square pi AB square by 4, and AB we know is 4R. So this will be 4R square by 4. This is pi 16R square by 4, which is equal to 4 pi R square. 4 pi R square. Okay. Okay. Now what is the area of the two smaller identical circles? So area of C1 will be equal to area of C2 will be equal to area pi R square, since we have considered R to be the radius of the two smaller identical circles. Okay, so this implies area of C1 plus area, that is the area of the two identical smaller circles, their total area will be equal to pi R square plus pi R square, which is equal to 2 pi R square. So this implies the area of shaded region, will be equal to the area of the bigger circle, which is 4 pi R square, minus the area of the total area of the two smaller identical circles, which is 2 pi R square, which is equal to 2 pi R square. So this implies the ratio, let's say the area of the shaded region be A1 and the ratio of the area of the shaded part to that of the big circle. Okay, and let's say the area of the bigger circle be A2. So we have, that is A2 is equal to 4 pi R square, and the area of the shaded region, that is A1, is equal to 2 pi R square. So we must have A1 by A2 is equal to 2 pi R square divided by 4 pi R square. Pi R square cancels out, and this is equal to half. So this implies A1 is to A2, that is the required ratio is 1:2. So the correct choice is A. A is the correct choice. Okay. So whenever you have the concept is that whenever you have two smaller identical circles, now in this problem the two circles inside the bigger circle, they are identical, but they may not be identical. But if there are two circles inside the bigger circles and they are touching each other, the concept is that the sum of the diameter of the two inner circles will be equal to the diameter of the outer bigger circle. That is the main concept. Okay, let's see the next problem. There is a figure. It says that the figure is made up of two quarter circles in a square of side x centimeter. Okay, so definitely let's say the square is AB, C, D is the square. Each side is x. The length of each side of the square is x centimeter. Okay, the perimeter of the shaded area is, okay, now it is given that the shaded region is the perimeter of the shaded region. Now the figure the figure is made up of two quarter circles in a square of side x centimeter. So basically one quarter circle, we know that a quarter circle is one fourth of a circle, or a sector where the central angle is 90 degree. So clearly we can see that one quarter circle is this one. This is one quarter circle, where we see that this quarter circle, or the quadrant, a quarter of a circle is also known as quadrant. We see that the radius is equal to x, that is the length of the square, x, and obviously this is 90 degree. Okay, so what will be, let's say, the curved line, let's say this sector B, A, and so we have this sector is ADB. Let's say this sector B is ADB. Okay, now the other sector is this one. This is the other quarter of a circle. This is D, B, and C. This is obviously 90 degree. So if you join the two sectors, ADB and DCB, you will get the given figure in the problem. So basically we have to find now what is the perimeter of the shaded area. Perimeter of shaded area is nothing but perimeter, not perimeter actually, length of arc. So dB is the arc, length of arc dB, length of arc dB plus length of arc. So this is also dB. Okay, length of arc dB. So we are having twice the length of arc dB. Length of arc dB. Now what is the length of arc dB? Now these two are quarter of a circle, or quadrant, and we know that the length of an arc, which is the length of the arc of a quadrant, is nothing but 1/4 of the perimeter of the circle. And these two quarter of a circle, the quadrant, these two quadrant are having a radius of x. So we can say that length of the arc dB, length of the arc dB should be equal to, we know that the length of a arc of a quadrant is equal to 1/4 the the circumference of the circle. So this should be equal to 1/4 multiplied by the circumference of a circle having radius x, which is 2 pi x. This is equal to pi x by 2. So the length of the arc dB, which is the part of the quadrant ADB. And what is a quadrant? Quadrant is also a quarter of a circle. That is a quadrant or a quarter of a circle is nothing but a sector having a central angle of 90 degree. So in that case, the length of the arc is nothing but 1/4 the circumference of the circle. Okay. Now, so this implies that the perimeter of the shaded area will be equal to, we can see it is equal to pi x by 2 plus pi x by 2, which is equal to pi x, So the correct choice is D. So sometimes you have to be you have to observe the figure carefully and understand the underlying figures. So clearly the shaded region is produced by the two identical arcs, which is these two identical arcs are the arc of a quadrant or a quarter of a circle, that is a sector having a central angle of 90 degree. So therefore, and the arcs, so this part, this arc and this arc, they are of same length, and the length is nothing but the 1/4 of a circle, 1/4 of the circumference of a circle having a radius equal to x, where x is the length of the side of the square. So I hope solving this set of 6 problems will give you a good idea of how to solve some relatively difficult problems based on how to find area of a shaded region based on circles and other figures like squares, rectangles and triangles. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So I have completed the chapter of mensuration. I think in the next video I will start the next chapter, which is, I think, data handling. So please stay tuned for the upcoming videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.